Right, in the first one, we're looking for perfect squares. Our index is an unwritten 2, so we're looking for perfect powers of 2 or groups of 2. And so we start with the number. Are there any perfect squares that are factors of 50? 25 times 2, right? So the square root of 25 comes out as a 5, and this factor of 2 is going to stay inside the radical. Okay. And what about the a? So we're looking for groups of 2. How many groups of 2 can we remove from the powers of a? So that comes out as a to the 4th, and how many a's will be left inside the radical? None. Now notice I applied this radical to each part individually, so to the numerator and the denominator individually. So now I'm going to move to the denominator, the square root of b to the 6th. So here we have, again, groups of 2. How many groups of 2 can we remove from the powers of b? 3. And how many b's would be left inside the radical? So is this your answer? What if I told you this is not quite the answer?
Absolute route.
Hey, yep, when you look, so you're dealing with an even indexed radical, so you do have to test for negatives. So let's go to the a's. Is it possible for a to be a negative in the original form? Yeah, you take it to an even power, becomes a positive. So when we check that, it is possible for a to be negative. If that's the case, we take that to a power of 4. Is there any way that this form will ever be a negative if the a is a negative? No. So the a takes care of itself, right? The power of 4 takes care of that. Okay? But when we look at the b's, we have a negative to the even power, so that becomes a positive. So b can be a negative number. So when we test that into our simplified form, if b were negative, does this form by itself guarantee you'll never have a negative solution? No. So what do you need around the b? Yep. So we need to put absolute value in here, and that now would be your accurate answer, the full, complete answer.